Imagine it's 2 a.m., production just went down, no alerts, no dashboard, and no idea what broke. That's where this story begins. In this 10-part monitoring and alerting in real life series, we start from zero, no monitoring, and build a complete production grade observability system from scratch. Prometheus for metrics, Grafana for dashboard, Alertmanager for notifications, and Slack for escalation, all connected, all real. We simulated real outages, trigger live alerts, and even created dashboards that react instantly when your application crashes. You'll see how real DevOps teams detect, escalate, and recover in motion. And the best part, you can download the complete source code for all 10 episodes by subscribing to my newsletter. You will have README file which consists of the demo, overview, and practice exercises, interview questions with interview answers as well. I will give the link in the description. Now sit back and enjoy the full journey. 10 episodes, one real world story from blind panic to full observability. It's 2 a.m., production is down. No alerts, no dashboard, no idea what's happening. Your phone is vibrating with customer messages. The site is not working. You log in, CPU may be high, maybe not. You can't tell, nothing is watching. This is what happens when you don't have monitoring in place. I still remember my first real incident. The customer called before we even knew the site was broken. We were guessing it. Is this the application, network, disk? Logs were scattered. Metrics? None. Dashboards? Zero. If you can't see what's happening, you can't fix what's happening. So, what exactly is monitoring? Monitoring is visibility, the art of turning chaos into measurable data. It stands on three pillars. They are metrics, logs, traces. Metrics tells us how much CPU, memory, latency is there. Logs tells us what happened. For example, errors, exceptions. Traces tells us where it happened, how a request moved through different services. Let's draw this out. User, load balancer, application, server, monitoring, visualization, alerts. Every arrow here is a blind spot. Our mission in this series is to add eyes at every layer until nothing can hide. Enough of talking. Now let's jump into the demo and feel the pain for real. Before we jump into the demo, hit that subscribe button right now because over the next few weeks, we are going to build a real world monitoring system from scratch. Prometheus, Grafana, Alertmanager, everything you'd see inside a production DevOps team. And trust me, by the end of this series, you will not just watch alerts, you'll feel like the one who built them. Alright, let's feel the pain first. Let's see what happens when we run an application with no monitoring at all. I'm in my Visual Studio Code right now. Here, if you see in the folder episode 1 no monitoring, I have application.py file, docker compose.yaml, docker file. It's a very simple Flask application, and also I'm trying to simulate a crash here on this step. Then we have docker compose.yaml. In this file, we are trying to create a service, web service, building the application, and then container name would be demo app, ports 5000, restart always. Then we have this Docker file. It's a very simple Docker file. We are using Python slim image, working directory, application directory. Then we are trying to copy the application, installing Flask, and then we are trying to run that application. Now let's try to start the container using docker compose up command. Press enter. Let's try to access website in the browser. For that, I'm going to open the browser. Then paste the URL. I can see application is running fine. Let's refresh a few times. I see internal server error. The server encountered an internal error and was unable to complete your request. Either server is loaded or there is an application error. Now let's jump back to our Visual Studio Code. I'm going to open another terminal. Now let's look at the logs. For that, I'm going to say docker logs demo application. Press enter. So I see some error stack. I see messages saying error in application, exception. So yes, the application crashed, but we still don't know why. Was the CPU overloaded? Memory leak? Container restarts? We can't tell. Logs give us what failed, not why it failed. Right now, we are reacting to symptoms, not understanding causes. This is where most teams get stuck. Logs are like postmortem. They tell you something died, but not why it was dying in the first place. We needed metrics. We need continuous visibility. We need to see the heartbeat of our system. What are the key lessons and takeaway? Monitoring isn't just about dashboards and graphs. It's about confidence. When you see what's happening, you stop guessing and start engineering. Today we felt the pain of flying blind. From the next episode on, we'll build our own production grade monitoring stack step by step. Prometheus for metrics, Grafana for dashboards, and alert managers for alerts. And remember, all these tools will come and go, but concepts like visibility and feedback never change. In episode 2, we'll give this system eyes, we'll install Prometheus and Node Exporter, collect our first metrics, and finally see our systems come live. Hit subscribe right now because next week your server learns to speak. Thank you for watching and see you in the next video. Last episode, we crashed an application and had no clue what went wrong. We saw logs, but they only told us something failed. Today, that changes. We are going to give our system eyes using Prometheus, the brain behind modern monitoring. Before we touch the terminal, let's understand the idea. What exactly is Prometheus? It's a time series database that collects metrics from targets every few seconds. Each target is like a server, container, exposes an HTTP endpoint called slash metrics. Prometheus pulls the data from all these servers and containers and it stores it with timestamp and let us query it later. Prometheus doesn't wait for data, it asks for it. This pull model from the server is what makes it predictable and secure. If you are enjoying this hands-on series, make sure you subscribe because we are building a complete production grade monitoring stack step by step. Alright, let's install Prometheus and Node Exporter. Let's build it step by step. In episode 2 monitoring folder, I have docker compose.yaml, prometheus.yaml file. First, let's look at the docker compose.yaml file. So we are going to use services here. Under services, we have Prometheus, the collector and database. Followed by, we have the second service as node exporter, the agent exposing system metrics. Here we are trying to use the official image, Prometheus latest version, followed by mapping ports 9090. The volumes line mounts our local prometheus.yaml config inside the container. The second container node exporter has the image, node exporter, latest, followed by ports 9100. Prometheus will soon scrape data from this particular port. Now let's look at prometheus.yaml file. Under global section, we have scrape interval means ask every 15 seconds. Under scrape config, we create one job named node. Static configuration targets, we have node exporter 9100. Now let's navigate to episode 2 so that we can spin up the containers. Right now I'm in my episode 2 folder. Here I am going to say docker compose up -d command once again. Press enter. If you see, it is trying to pull node exporter and it says already exist, pull completed successfully. And if you scroll down, our containers started. Now let's jump back to our browser. Here I am going to navigate to localhost 9090, press enter, and here we are. We can see our Prometheus is ready. And we see a lot of options here. And here we are. I can see Prometheus successfully. Here I see alerts, graph, and status. In status, there are multiple options: runtime and build information, command line flags, configuration, rules, targets, service discovery. I would like to jump into targets. Here you can see our node exporter state up 1/1 up, our first heartbeat. Now let's jump back to our Prometheus. Now watch this. When I search for node CPU seconds total, click on execute, Prometheus returns live CPU data for each core and mode. You see fields like CPU, mode, job, instance. That's the real system telemetry flowing every 15 seconds. Each value here is a time series point. It tells Prometheus exactly how your server is behaving. This is the heartbeat of our system, the first proof that our monitoring setup is alive. It may look simple, but the structure Prometheus plus node exporter is the backbone of enterprise level monitoring. Prometheus is the brain, exporters are the senses, and soon Grafana will be our eyes. In episode 3, we will connect Grafana to Prometheus and create a beautiful real-time dashboards. You will see CPU, memory, and container stats dancing live. Subscribe now. Next week, your metrics will get a face. Thank you for watching and see you in the next video. Last time, Prometheus started collecting data. We could see some metrics, but these were just numbers. Today, we'll bring those numbers to life with Grafana. Real-time dashboards, instant insights, and the kind of visibility companies rely on every single day. Right now, Prometheus scrapes data from node exporter every 15 seconds and stores it in a database. What we need next is a way to visualize. That's where Grafana comes in. Prometheus is our data brain. Grafana is our window to it. Prometheus collects and stores data. Grafana queries using PromQL and turns the data into graphs and dashboards. It's the difference between reading numbers and seeing what's really happening. Before we dive into this setup, hit subscribe right now because over the next few episodes, we are not just creating dashboards, we are building a full monitoring ecosystem with alerting, Slack notification, and production ready reliability. If you ever wanted to feel like a real DevOps engineer, this series is your playground. Alright, let's build Grafana. I have episode 3 folder here with docker compose.yaml file and prometheus.yaml file. In docker compose.yaml file, I have services. Under services, we are using Prometheus. It's the same docker compose file from episode 2. Followed by we have node exporter. I already explained about this in episode 2. We are adding a third service, Grafana, with image Grafana. Ports here would be 3000. Environment, username, password. I am hard coding this for simplicity. You can create .env file and try to pass these variables. We are going to build production grade stack in the coming episodes. For now, I am going to keep it simple so that it will be easy for you to understand. Now we are going to start our containers. For that, I'm going to use Docker Compose, up space -d, press enter. So I can see the container started. Let's check if the container started successfully. I'm using Docker PS to check. I can see 3 containers started. Now let's jump back to our browser. So in browser, I'm going to go to localhost 3000. And here we are. Welcome to Grafana, your new monitoring control center. Let's write username and password. I'm not going to save this. It is asking me to update password. So I'm going to update my password here real quick. If you want, you can skip this as well. Skip this step, but I don't want to skip. I'm going to continue with this. So we are into the Grafana dashboard. You can see lot of options here: bookmarks, stacks, dashboard, explore, drill down, alerting, connections, administration. You can see a lot of information inside this. You can go through information slowly. In the beginning, it might be overwhelming for you, but slowly you will get used to it. I'm going to click on connections and data sources. I can see I would like to add data source here. So that would be our Prometheus. So I'm going to select this Prometheus. Here we need to provide the URL. So I'm going to provide my local container URL here. For that, Prometheus colon 1990. Followed by, let's try to save this and see if it will work. I can see successfully queried the Prometheus API. Now let's go to the home. So we have successfully connected the data source. I can see Prometheus connected. There is an option to build a dashboard from here. I'm going to click on build a dashboard. Then add visualization. So I'm going to select data source as this Prometheus. So here we have so many metrics. So for example, let's try to select node CPU seconds. So for that, I'm going to say node CPU seconds total and then run queries. You can see the visualization here. I would like to go with bar chart here, or let's say go with statistics. You can see stats as well. You can see pie chart. I mean, there are a lot of options that we can explore in this. So for now, let's keep it simple. I'm going to place bar chart here and I'm going to save the dashboard. Give the dashboard a name. Now let's give it a name, CPU monitoring. I'm just giving a random name just to show you guys. So home, I can click on dashboards and I can see my CPU monitoring dashboard. If we click here, you can see the panel. From here, you can monitor what's going on. You can add so many different metrics and so many different panels, resize and arrange them. This is your system's live health dashboard. Grafana doesn't store any data. It reads directly from our data source, Prometheus, in real time. Every few seconds, the graphs updates automatically. So for example, if I come back here, I can see last 5 minutes what's going on, or I would like to see last 24 hours, or you can go for last 7 days. I mean, there are so many different possibilities here. You can also import existing dashboards. There is an option to create new dashboard, new folder, and also you can import existing dashboards. Let's do a quick recap. Dashboards are great, but what happens when something crosses a limit? So far, we have seen Prometheus, the data brain, Grafana, visualization layer, node exporter, data collector. In episode 4, we are going to add Prometheus Alert Manager and Slack notification so the system actually talks to you when things go wrong. Subscribe now because next week your systems won't just see, they will speak. Thank you for watching and see you in the next video. Dashboards are great, but they don't wake you up at 2 a.m. What if your server crosses 90% CPU and no one notices? Today, we'll wire Prometheus plus Alert Manager plus Slack so your system speaks before users complain. We will start the stack, explain each and every file, deep dive node exporter, and watch a real alert hit Slack. The flow is very simple: node exporter, Prometheus, alert manager, Slack. Node exporter reads host metrics. Prometheus evaluates alerts. If a condition holds, Prometheus marks it firing and hands it to Alert Manager. Alert Manager decides where or how to notify Slack, for example, or email or Teams channel. We can have multiple options in this place, but for today, I want to keep it very simple and we are going to go with Slack. Before jumping into the demo, hit subscribe. Next episode will stage a production style outage and let alerts guide our debugging live. So I have episode 4 folder alerting. In this folder, I have alertrules.yaml file, alertmanager.yaml, dockercompose.yaml, prometheus.yaml. First, I would like to start with dockercompose.yaml file. So in this file, we have seen in previous episodes, we had Prometheus, node exporter, followed by Grafana, and we are trying to add a new service, Alert Manager. First of all, before going to Alert Manager, I would like to give a small explanation here about node exporter. Previous node exporter had only image and ports, but this node exporter comes with PID. So what exactly is PID here? PID is nothing but process ID of our host machine. With host PID, it reports real host CPU, which is what we want for alerts. And in terms of volumes, we have proc, which is pointing out to host proc read only, /sys, host sys, then root fs. This combo makes node exporter behave as if it's running on the host even inside Docker. We are going to ignore this collector file system, mount these long expressions which we have, because on Windows WSL plus Docker desktop, you will see sudo mounts like /mount/WSL Docker desktop bind and stuff. These can create invalid file system metrics and noisy warnings like metric was collected before, skip noisy path, skip file systems. We are trying to add these flags here. Then we have Alert Manager with image and ports, followed by we are trying to attach alertmanager.yaml file. So this is the file we are trying to attach. Now let's jump to the Prometheus.yaml file. In this file, the same, I think I already explained about this. We are trying to scrape this data for every 15 seconds. Then we have scrape configuration, job name, static config, followed by we have rule underscore files. It tells Prometheus where your alert rules live. We are trying to keep the rules in a separate file, as you can see, alert rules.yaml. Then we have alerting. This is nothing but dispatcher connection. Prometheus doesn't send Slack, it forwards firing alerts to Alertmanager at this particular port 9093. Alertmanager then groups, deduplicates, throttles, and send notification to Slack. Without this particular block, Prometheus would detect issues but stay silent. Now let's look at the actual alert rule. So what do we have here? Here we have groups, then followed by node alerts name, rules, alert name is high CPU usage, expression. We are trying to calculate average rate of node CPU per seconds total. Mode is user. For 1 minute, multiplying by 100, it should be less than 80. In production, it would be greater than 80. Wantedly, I am keeping it less than 80 so that we'll have some alerts. For 10 seconds, prevent noisy flip-flops. The condition must hold for 10 seconds to fire. Then we have labels, severity warning, annotation, summary is high CPU usage detected, description CPU usage less than 80% for more than 1 minute. So if this particular condition meets, then we are going to get the Slack alert. Now let's jump into the alertmanager.yaml file. Here we are trying to set the route. Receiver would be Slack notifications, receivers name, Slack config, send resolve true, the channel name, username, icon emoji, then the API URL. We have to create this on Slack. I'm going to show that in a moment. Once we have the URL, we are just going to replace this particular URL. Now let's jump back to Slack. So here I'm going to create a new channel. So for that I'm going to say add channel, create a new channel. Next, I would like to give channel name, for example, DevOps alerts, public anyone can access, or private only specific people can access. So I would say monitoring, because I think I already used this particular name. So I would say DevOps alerts monitoring, create, skip for now. We have the channel in place. Followed by I'm going to go to api.slack.com. Here you can create a new application. You can do it from a manifest. I would like to do it from scratch. Click on this and then application name. So what exact name you would like to give here? So I would give a name as Prometheus Alert Bot. Followed by select the workspace, Learn with DevOps Engineer, create application. It will take a minute. Followed by on the settings page, click on incoming webhook. Here try to turn on this. Followed by add new webhook. Then select the channel. So DevOps alert monitoring, which we created just now. DevOps alerts monitoring. Click allow. Once we have that, you will see a success message. Copy this URL. Go back to Visual Studio Code. Here we are going to replace this URL with the URL which we copied just now. Normally this should not be visible in production environments. We are going to use a different approach. we are trying to use environment variables and try to pass the URL, or in CI/CD pipelines, we are going to pass this particular variable. Now we are ready. We need to update the channel name here. So for example, I'm going to go back to my channel. I would like to copy this channel name so that I will not make any mistakes. Jump back to Visual Studio Code and I would like to paste it here. Save this. Also, I would like to save this file as well. Now we are ready with all the files and configurations. Let's start our containers. For that, I am going to say docker compose up space -- build. As soon as our containers are up and running, we are going to jump back to our browser and access Prometheus. Looks like our containers are up and running. Now I'm going to use localhost /9090 port. Press enter. Our Prometheus is running fine. If you see, let's go to our alerts. I don't see any kind of alerts. Let's go back to our rules. I do not see any kind of alert rules here. So there is some problem. Let's jump back to our container and see what's going on. Why are we not seeing these alerts? So for that, I would need my container name first. I would like to copy my container name. So in this case, it would be episode 4 alerting Prometheus 1. Clear the screen. Followed by, I am going to execute this command. What exactly I am trying to do here? I am getting into the container and trying to list /etc/Prometheus folder to check if we have alertrules.yaml file. Press enter. Normally we have alertrules.yaml file, prometheus.yaml file. I see only prometheus.yaml file, so this is the problem here. Looks like we did not add the volumes, I guess. Yes, I can see prometheus.yaml. Let me check if we have alertrules.yaml file as well. No, I do not see. I see alertmanager.yaml file. Looks like we did a small mistake here. So these kind of issues we do in real environments as well. So it's kind of common. So I'm going to quickly add that file here. alertrules.yaml /etc/Prometheus. I'm going to do the exact stuff which we have at Prometheus line followed by alertrules.yaml. Now hopefully after adding this particular line, we should be able to see our alert rules in Prometheus. Let me close this real quick and I would do a docker compose down and docker compose up -- build. So I'm trying to destroy everything and recreate so that it would be easy. Now let's jump back to our Prometheus, refresh this. Here we are. I can see node alerts. Let me go back to alerts and I can see high CPU usage, 0 active alerts. Inactive, slowly it should change to pending, then it comes to firing. Also, if you look at the Slack channel, we don't have any kind of alerts. Now if you see, it came to pending state. From inactive to pending state. It will wait for 10 seconds here in this particular state and it will move to firing state. Let's look at what exactly happening in our alert manager. I don't see anything yet. Once we have in firing state, we should be able to see in alerting manager as well. Now from pending state to we have it on firing state. You see inactive, pending and firing. Hopefully we should see that in our Slack channel as well. Yes, firing 1, high CPU usage warning. And if you go to alert manager, we can see that here as well. Info, source, silence and also the link. This is how you try to configure self-aware monitoring system. Now let's do a quick recap of today's episode. Node exporter. It try to read the host metric, which is nothing but our sensor. Prometheus evaluates rules. This is our brain. Whereas Alert Manager routes and dedupes. It is our dispatcher. Slack delivers the message, the voice. Together, it's a production grade alerting pipeline. You built a self aware monitoring system. We can extend the same pattern to memory, disk usage, container restarts. I mean, we can do a lot of stuff with respect to different alert rules. Next episode, we will see a real outage simulation guided by alerts. Subscribe and let's keep building systems that talk before users complain. Thank you for watching and see you in the next video. It's 2 a.m. again, but this time we are not blind. Prometheus is watching. Alert Manager is listening. Slack is waiting. Today we'll simulate a real production failure. Watch Prometheus detects it and see the alert fire live across Prometheus to Alert Manager and from Alert Manager to Slack. By the end of this video, you will understand exactly how alert rules work and why they are the heartbeat of every monitoring system. In the last few episodes, we gave our system eyes with Prometheus and dashboards with Grafana. Now we will give it reflexes, the ability to scream for help when something goes wrong. Before we break production, hit subscribe so you don't miss the next episode where we'll build a full application health dashboard. Let's jump into our Visual Studio Code. In our Visual Studio Code, I have episode 5 application failure alert folder. In this folder, I have multiple folders: Alert Manager, application folder, Prometheus, scripts, and docker compose.yaml file. So first I would like to start with application folder. In this folder, I have application.py file. If you are following my episodes, I am using the exact code from the previous episodes. I am updating some changes which I am going to explain now. So here is our updated Flask application. 30% of the time it deliberately returns a 500 error and increments a custom Prometheus counter called app underscore error underscore total. Every time that happens, Prometheus can scrape it from the slash metrics endpoint. So our app is now instrumented. It reports its own pain back to Prometheus. Next, in Prometheus.yaml file, we tell Prometheus to scrape every 15 seconds Followed by we have a job name application. Here Prometheus constantly pulls the latest metrics from web columns 5000, nothing but our slash metrics endpoint. Simple but powerful. Prometheus now knows our app exists. Here's the magic part, our alert rule. Let's unpack that slowly. First, we have a name, app alerts, followed by rules, alert, name of that, application error rate high, expression. This is the PromQL logic Prometheus evaluates every few seconds. Increase app error underscore total 1 minute greater than 0. What exactly mean by this expression? Has this metric increased in the past minute? If yes, fire the alert. For 0 seconds means fire immediately. Don't wait to confirm again. This is best for demos as I am showing you right now. In production, you might set for 1 minute so it only alerts if the error rate stays high for a full minute. Then we have labels with severity, critical in our case. Then annotations are the human readable parts, what shows in Slack and Grafana. Application error rate high, more than 2 errors were detected in the last minute. So line by line, this rule turns raw metric data into human readable actionable intelligence. Then we have our alert manager setup, which I already explained in previous episodes as well. Here we receive alerts from Prometheus and decide what to do with them. For our demo, we are trying to send it to DevOps alert monitoring channel with the API URL which we generated in our last episodes. Now we start everything with docker compose up --build space -d command. Press enter. Our containers started successfully. Now let's jump back to our browser and try to see if they are available. So I can see application running on localhost 5000, followed by I have Prometheus, wherein I'm going to refresh this page. I can see Prometheus as well, and also I can see the alert rule inactive. Then we have alert manager, no alert groups found. We have Grafana dashboard, and then we have our Slack channel where we are going to receive the messages. Before doing anything here, I would like to run a simple script. It's a shell script wherein instead of refreshing it manually, I'm going to do that using the script. So let me run that script real quick. Fire errors.sh, press enter. Watch this. Slack lit up, application error rate high. At the same time, if I jump back to my Prometheus, I can see alerts firing, and also in the alert manager UI, it shows as active. That's real time detection, no manual log digging, no guessing. When the app stops erroring and increase value returns 0, Prometheus evaluates again and marks the alert as resolved. Then Alert Manager sends a calm green message saying resolved. Application error rate back to normal. That's a full life cycle trigger. Notify, recover. When the app stops erroring and increase app error totals returns 0, Prometheus evaluates again and mark the alert as resolved. Alert Manager sends a calm message resolved. Application error back to normal. Let's check that in our Slack. Here I can see resolved. That's a full alert life cycle: trigger, notify, recover. I stopped this script. That's why we are not seeing any kind of error messages. And also on the application level, it shows application is healthy. For production, you would tune this rule carefully. Maybe alert if errors greater than 5 for 5 minutes and group by service name. That prevents alert fatigue but still warns you before users notice downtime. For production, you would tune this rule carefully. Maybe alert if errors greater than 5 for 5 minutes and group by service name. That prevents alert fatigue but still warns you before users notice downtime. And if you ever wondered why sometimes Slack shows an alert that you don't see in Prometheus, it's just timing. Prometheus evaluates every few seconds, and if the condition flips fast, Slack catches it first. From episode 1, no monitoring, to episode 5, instant Slack alert confidence. That's a real world monitoring pipeline. Next, we are going to bring these alerts into Grafana dashboards. For a full application health view, subscribe and stay tuned because now our systems doesn't just speak, it tells stories. From chaos to clarity, one alert at a time. Thank you for watching and see you in the next video. Our system can detect problems and alert us instantly. But reading text alerts isn't fun when you are on a call at 2 a.m. Today, we'll build a live Grafana dashboard, a real-time control room that shows CPU spikes, application errors, and active alerts in one place. By the end, you will see systems heartbeat on screen, every pulse, every failure, every recovery. In episode 5, Prometheus detected random app failures and we got alerts to our Slack channel. Now we are going to take those same metrics and visualize them in Grafana because monitoring without dashboards is like driving without a speedometer. Before we dive in, hit subscribe. The next episode is our first real outage simulation. And trust me, you will want to see that one live. Alright, let's jump into the demo. Now let's jump into our Visual Studio Code. In our Visual Studio Code, we have episode 6 visualization, and the structure is similar to episode 5. We are doing the exact same stuff, but we are trying to create new dashboard. So let me jump back to episode 6 real quick. So episode 6, we are going to start our containers now using docker compose command. Press enter. As soon as we have containers up and running, we are navigating to Grafana dashboard. So I'm going to open my browser. It is running on localhost 3000. Refresh it. And we have to give username and password. So I'm going to give that real quick. Login. And here you can update the password if required. If not, you can skip it. This is only for testing purposes. Production, we are going to have a very strong password and stuff. So for now, I'm going to skip this. So as soon as you skip, you are going to land into our Grafana website, wherein we have dashboards and there are, let's say, multiple other features. If you see dashboards, drill down, metrics, logs, traces, I mean, there's a lot of information here. So first things first, before we even create a dashboard, we need to add data source first. So data source, what exactly is data source? So I'm going to add data source. This is our Prometheus, wherein we are going to get metrics from. And here I would like to give Prometheus 9090 port, followed by save those changes, and we can see successfully queried the Prometheus API. Let's go back. Now let's go to dashboards. So under dashboards, we are going to create a new dashboard. Click on create new dashboard, and we are going to add a visualization panel. So I'm going to select Prometheus as data source here, followed by I would like to give it a name here. So for example, we can give it as, so I'm going to give application errors over time, followed by, if I scroll down here, here we have builder options wherein manually you can give that, and also there is a code option. So I would like to enter a PromQL query. It's a very simple query. We already did it in our previous episodes as well. I try to explain alert rules using this particular query language only. So what exactly we are doing here? Application errors total is the counter we created in our Flask application, then increase by 1 minute. How much did this counter go up in the last minute? Every time our app throws a 500 error, the counter increases. So this query literally tells us how many errors occurred per minute. Then in the visualization section, we are going to select time series. There are other options as well. So for this video, I'm keeping it simple. Let's keep it with time series. Save the dashboard, and instead of new dashboard, I would say application health dashboard. Okay, save it. So as soon as we save, we should see some data here. I'm going to go back to my dashboard. So here I can see application errors over time. Okay, followed by we are going to create few more panels so that our Grafana dashboard looks interesting. And now let's try to add another panel. So visualization panel. So in the title, it would be CPU and memory usage. Then in the code, we are going to say enter PromQL. So for example, I can give this number here. So what exactly we are trying to do here? It takes all CPU cores, measures how much time they spent not idle in the last minute, and we are trying to convert into a percentage. So for example, if the graph hits 90%, your server is sweating. Now the same we can do it. Let's say we can add another query expression. So let's try to add memory here. What exactly this query is doing here? It will try to calculate the percentage of RAM currently in use. When memory is, let's say, more than 80%, it's kind of a warning sign where slowdown begins. Together, these two queries shows if your system's slowness is hardware stress or code bugs. I'm going to save this once again. Save, go back to the dashboard. Here now I can see two panels, CPU and memory usage, application errors over time, followed by let's try to add third panel. So in the third panel, let's try to give name as active alerts here in the title, followed by we are going to write the query once again. So this is very simple. Once again, it's a built-in Prometheus metric that lists all alerts currently active. So whenever application error rate high fires, this box lights up red. So for now, I'm going to keep it very simple and save this dashboard. Save, back to dashboard, and last panel. So what exactly we are going to add here? So in this panel, I would say we are going to check the uptime of our application. So for that, I'm going to say time process start time seconds is when the application process begin. Subtracting one from the other, and we get the uptime in seconds. Grafana can format it into hours or days if this number resets frequently. It means your container is, let's say, crashing all the time. All right, so let me give it a name. Here it would be app uptime. Save the dashboard. Save it. Go back to the dashboard. So now we have all the panels in place. So I'm going to rearrange a bit so I can drag and drop here. So for example, I would like to keep application errors on top so that as soon as I log into the dashboard, I can see that. Followed by, I will keep CPU and memory next to my application errors. So I will make it a bit small so that it will be easier to view. I can see app time, and I can see also app active alerts. So I can drag and drop and rearrange a bit. So overall, yeah, this is how it looks like. Okay, now we can see everything arranged clearly. I can see application errors over time, CPU and memory usage, app uptime, active alerts. Now let's try to refresh this. So I can see some graphs spiking in. I cannot see any active alerts. I can see app uptime, application errors over time, CPU and memory. So at a glance, if you see the colors, green means it's healthy, yellow means kind of warning, red means critical. I also did not update any kind of colors to the panels. That's fine. But yeah, let's jump back to our Visual Studio Code. Now here, I'm going to jump back to my scripts folder and let's try to fire some errors. So that would be 100. Now let's watch our dashboard. I can see application errors graph spike upwards. And if you see the active alerts, I can see some alert messages were sent to our Slack channel. That's full circle observability, metrics, alerts, and visuals all working in sync. This isn't just a toy setup. This is how real DevOps teams watch production systems in real time. Let's do a quick recap of this episode. We started this series completely blind, no monitoring, no alerts. Now we have a system that collects data, detects anomalies, alerts on failures, and visualizes everything beautifully. Metrics, alerts, dashboard, action. That's the real DevOps feedback loop. Next time, we'll simulate a full production outage. Use this dashboard to diagnose it live and recover fast. Subscribe and turn on notification because next episode things are going to break. From metrics to meaning, that's the Grafana way. Thank you for watching and see you in the next video. Everything is calm, dashboards are green, CPU is stable, and Slack is quiet. But one hidden bug, one small mistake, and production crashes. In this episode, we will simulate that exact moment, a total outage. We will trigger the failure live, watch Prometheus detects it, Grafana lit up red, and Slack scream for help. Then bring everything back to green. In episode 6, we built our application health dashboard. where we have application errors, CPU and memory usage, active alerts, and application uptime. Now, we will use this dashboard during a real outage to see how observability actually saves you under pressure. Before we crash production, hit subscribe so you don't miss the next episode where we build smart alert priorities and escalation rules. Now let's jump into our Visual Studio Code. So in my Visual Studio Code, I have episode 7 production outage. In this, I have Alertmanager, application folder, Prometheus, and the scripts. Also, Docker compose.yaml file. First, let's discuss about Docker compose.yaml file. It's almost similar to our previous episodes. I just changed few things. I will try to give you a brief update about this particular file. First, we have web service, which is our Flask application, followed by I try to add one environment variable, fail mode is equal to false. Then we have Prometheus as usual. I did not change anything there. Followed by node exporter. Then we have our alert manager. Finally, we have Grafana dashboard, which we were building from past episodes. Here, if you see, I tried to add volumes, Grafana data, and also we need to add it here in the end as well. This volume will not affect your dashboards. For example, if you shut down your container, your dashboard's data will not go anywhere because we are creating volumes so that all our data is going to store in this particular Grafana data volume. So it keeps all dashboards and settings safe even if I run Docker Compose Dawn. This is what makes our monitoring setup production ready. Now let's try to look at our application file. So in this file, we are trying to add a hidden switch if a file called tempfailmode.flag exists. It will fail every request with 500 errors. The moment this file is created, every request starts returning simulated application error. Now let's try to start our stack. I'm using Docker Compose up once again. Press enter. As soon as we start our containers, we should see everything running. I will jump back to my dashboard. I'm going to refresh this page. I don't see any data here. That's good. And I will try to refresh this page as well. And Alert Manager is okay. Followed by Prometheus is also okay. Then I have my application here. Followed by, let's look at our Slack. I don't see any error messages here as well. Now, we are going to simulate the failure. First of all, let me clear the screen. Then I am going to execute Docker execute command I'm going to run, followed by web container, and we are trying to touch this particular file. I mean, we are creating this file. Press enter. The moment this file is created, every request starts returning simulated application error. Now let's jump back to our browser and try to refresh this page, and I see an error. I will try to do it multiple times. I am seeing the same error. We just reproduced a production level bug instantly without restarting anything. Within seconds, Prometheus will try to detect that and it will try to start firing the alert. And the alert manager will also see that. Then let's jump into our Grafana dashboard and try to refresh here. And here I can see application errors over time. Previously there was nothing. Also, let's try to fire more errors. I'm going to run my script fireerror.sh. So it will try to send many requests. Also, we can see in Slack channel as well the error message. So I see so many errors here. That's real time observability. detection, alert, notification, all automated. Now let's try to figure out what exactly happened. Grafana shows error spikes, but CPU and memory usage are normal. I don't see any spikes here. So this isn't a hardware issue. It clearly shows that it is an application level issue. Let's try to confirm with logs. I'm going to jump back to my Visual Studio Code once again. Now let's try to look at the logs and confirm. Docker logs, web is my container name, hyphen tail 10. I would like to see last 10 lines of the log file. Press enter. So here I can clearly see repeated simulated errors. 500, 500, 500. We didn't guess. We verified through metrics and logs. Now let's try to remove that file real quick. So I'm going to say docker execute interactive mode web container, and we are trying to remove this file. Press enter. As soon as we remove this, we shouldn't see any kind of errors. Now let me go back to my browser and do a refresh. I can see application is healthy, resolved. Also, if we go back to our Prometheus and Alertmanager, we should not see any kind of messages. And let me refresh my dashboard. Here if you see, my spikes came down. They came back to normal. Now let's do one more simulation. So now I will try to stop our web container using docker stop command. Press enter. As soon as we stop, if we jump back to our Grafana dashboard, I don't see any metrics here. Grafana's availability panel flips because it uses up job is equal to app as the query. Let me show that real quick. So here we are trying to use this query up job is equal to app. This time we lost the heartbeat completely. No metrics, no response. Save the dashboard, come out of this dashboard, and now we are going to start that service real quick. Docker start web. The up metric returns 1. Grafana should go green. Grafana should go green once again. And we should see some metric here. Let's wait a minute. And if you see, after this particular point, 925, I can see the metric again at 928. So from this time to this time, there was no metric because our application was down completely. Let's do a post-mortem recap. We simulated 2 real-world failures. One, application failure where service runs but return errors. Second, service down, container offline completely. Prometheus caught errors, Grafana visualized, and Slack alerted instantly. That's exactly what happens in real on-call situations. Notice how we never guessed. We observed data, correlated metrics, confirmed with logs, and acted fast. That's what separates monitoring from true observability. And with small Grafana volume, our dashboards persist even after restarts, just like in production. Next, we will add alert priorities and silencing rules so you get notified smartly, not loudly. Subscribe because next episode we make monitoring smarter, not noisier. Every failure teaches you something. Observability makes sure you never miss the lesson. Thank you for watching and see you in the next video. In episode 7, we watched Prometheus catch our application failure and Slack lit up instantly. But in real companies, that's where the real problem begins. Too many alerts, CPU warning, memory warning, disk space issue, application errors, and suddenly your on call phone buzzes all night. Today, we will fix that by building smart alert logic with Alertmanager. Priorities, silencing, and escalation. Let's make alerts meaningful again. Our monitoring stack is live. Prometheus scrapes data, Alertmanager sends it, Grafana visualizes, and Slack notifies. Now it's time to organize all the chaos into structure. So only critical alerts reach humans. Before we clean the noise, hit subscribe because next episode we will build a smart on-call dashboard that shows everything at a glance. Let's start with understanding the problem. So what exactly is the reality? Most teams get flooded with alerts that all look urgent. The key to surviving this is alert design. Every alert should answer two questions. Number one, how bad and who should care? That's exactly what we'll implement now. Let's understand Alertmanager concepts as well. What exactly Alertmanager do? It will try to group alerts followed by assign severity and decides where to send them. In the last setup, we sent everything to Slack. Let's open alertmanager.yaml and make it smarter. Now let's jump into our Visual Studio Code. Here we have episode 8 smart alerting folder. In this folder, we are going to start from application folder. Here I have application.py. This version of our Flash service can now emit both minor and major issues. So Prometheus can classify them. If you look at here, 20% of requests will create soft 400 warnings and 10% of requests will be 500 critical errors. Also, we have a fail mode flag forces a complete outage. Now let's look at the Prometheus folder. Here we are going to look at alert rules first. I have two alert rules defined. One is application warning rate high and the second one is application critical error rate high. Prometheus detects problems by evaluating metrics against thresholds. We have two alert rules: app warning rate high, and the second one is application critical rate high. 3 minor issues in a minute, we are going to get this warning. If not, any critical alert, immediately we are going to get this message. Now let's jump back to our alert manager. Here, by tagging each alert with alert name and severity, for example, here I am trying to say warning and critical, it will try to come to our two different channels. One is Slack dev channel, wherein we have Slack dev warnings, followed by DevOps alerts monitoring. This is for on call. Simple warnings will come to this channel, and critical will come to DevOps alerts monitoring. Alert manager can route them differently. Developers will handle warnings. On call engineers will handle criticals. That's how you scale alerts in real teams. Now let's jump into the browser alert manager. Now imagine you are deploying a new version. You know alerts will fire, but you don't want Slack blowing up. That's where silences come in. We are going to create a new silence now. Now we are going to create a silence. For that, I would say new silence, followed by, I would say alert name is equal to app warning rate high. We are going to set the duration to 1 hour. Then we are going to write our name, for example, Arbaz, followed by, we would say testing new release. Click on create. So as soon as we create, I need to click plus button here. As soon as we create, we should see silences active. The silence activates immediately. Warnings still appear in Prometheus, but Alert Manager won't forward them to Slack. Once maintenance ends, just expire this or delete this silence. This is exactly how on-call teams stay focused during deployments. Mute predictable noise, watch for real failures. Now let's look at the alertmanager.yaml file. This particular file controls routing and escalation. Here grouping stops duplicate alerts, warnings are going to developers, and criticals page the on-call team. That's escalation done right. Now let's trigger some errors and watch it work. Now I try to run the script. If we jump back to our Prometheus, I can see app warning rate high. And if I check my Slack channel, I don't see any incoming messages because in Alert Manager, we try to set up silences. If you see, it is active, one active, it shows firing, but we are not seeing any messages in our Slack channel. That's how we try to silence our alerts. So after some time, these alerts are gone from Prometheus. And if you see, Alert Manager still has our silences. And if I try to refresh it, I do not see any kind of messages in my Teams channel. Now let's try to break it even harder. Now let's try to create a file using docker execute command. Press enter. After that, I am going to fire some errors once again. Press enter. I get 500 errors continuously. Now we did fire some alerts. If I jump back to my browser, I can see app warning rate high followed by app critical error rate high. And I can see two firing. If I jump back to my Slack channel, we should see application critical error rate high. If you see, we can see this particular error. If I check my dev warnings, I do not see any kind of errors because of silences. Let's do a quick recap of today's episode. We built a foundation of incident response. Incident response. Prometheus detects it. Alertmanager classifies. Slack routes to the right team. No noise, no confusion. Warnings go to developers for early actions. Criticals wake up on call engineers. That's how you prevent burnout and keep production stable. Next episode, we will visualize all of this in Grafana's command center. A live operations screen that shows your entire system breathing in real time. Subscribe and stay tuned because the next episode looks like an actual company's NOC. Don't fight alert noise, design it. Smart alerts mean calm engineers. Thank you for watching and see you in the next video. Before we start, quick challenge. If you ever stared at a blank Grafana screen wondering what to visualize, this video will change that. Hit subscribe right now because by the end you will build the exact command center dashboard that production teams use to catch slowdowns before users even notice. Now imagine walking into a company's operations room. Lights low. One giant wall showing services, alerts, latency, and uptime breathing in real time. That's not movie magic, that's Grafana done right. Today, we'll build that live dashboard and watch it respond to real latency spikes in our application. So, what exactly we are going to build today? We are going to create 4 panels. Number 1 would be uptime status. Number 2 would be P90 latency. How fast 90% of your requests complete. And number 3, error rate graph. Followed by finally, that would be active alert speed. In the last episode, we built smart alert routing and silences. Now it's time for visibility. To watch system breathe. Before we build, what's P90? It stands for 90th percentile latency. That means 90% of all requests will finish at or below this time. If your P90 is 1 second, most users are fine. The slowest 10% feel lag. It's the industry standard metric for real performance. Now let's jump into the demo. I already have episode 9 command center folder, and I'm trying to use the same exact source code here as well. Already started the containers. Now let's jump back to our Grafana dashboard. Here we are going to start by adding a source. So for that I would say Prometheus. We already did this. Once again I'm trying to show the same stuff. Then we are going to save and test it. So as soon as this is done, we are going to go back to the dashboard, and in the dashboard I would say create new dashboard and try to add visualization here. And then we are going to select the source, that is Prometheus, followed by I'm going to scroll down here. There are, let's say, two options, builder and code. And in code we are going to write up job is equal to application. Okay, this is what we are going to write. And in the visualization I'm going to select statistics here. I don't see any data. And if we try to scroll down, we'll see so many different options. I was already discussing about all these options. Now we are going to scroll down, look for unit. We are not going to select anything here. I would give the title as app uptime statistics. Scroll down and let's look at the color mode. So we are going to give color mode a value, background solid, for example. Now let's try to scroll down. Here I can see thresholds. I would like to add another threshold here. This time it would be 0.5. So I'm going to change the color to green, and the base color would be red color. So if something goes wrong, Grafana reads bottom up, so base applies first. When the value crosses 0.5, it flips green to show healthy. That's the cleanest way to track binary uptime. We are going to save this dashboard and try to give the dashboard name command center. Save. Done. You see it changed the color to green because it got the metric already. Now we are going to add a second panel. That would be once again visualization, followed by we are going to say P90 latency as discussed. In the visualization we are going to select time series here, followed by I'm going to scroll down and look for units. So under units we are going to add seconds. Under units we are going to add custom unit seconds, followed by we are going to update the line width to 2, and fill opacity would be 30%. Okay, fine. Now we are going to save this as well. Save. Go back. Now we are going to add another panel. The panel name would be error rate. So I'm going to write error rate here real quick, followed by we are going to add the query. So the query would be sum of rate of application errors total 1 minute by type. Then we are going to scroll down and add threshold lines once again. So threshold value here would be 2 for yellow, followed by I'm going to add another value 10 would be red. It's a simple visual. Red means we are in trouble. Followed by last but not least the final panel. Now let's try to create a new panel with active alerts. So for that I'm going to create new visualization here, and under panel options I would give the title as active alerts, followed by in the query we are going to say alerts is equal to active alerts, alert state is equal to firing, followed by I would like to change the visualization to table format. And then we are going to jump back to transformation, add a new transformation here. That would be label to fields, and select rows here, followed by each alert now becomes one row with columns like alert name, severity, instance, value. Then we are going to add another transformation. For that, I would say organize fields by name. Then we are going to scroll down here a bit, and I would like to minimize all of these options. Now let's try to add value mappings. So under value mappings, I would give a warning here, value, and the color would be orange, followed by another value would be critical errors, and the color would be red color. Update this. Then I'm going to show you another interesting thing now. So usually whenever we create panels, if you see, I don't see any data here. Okay. Now I would like to add something there. For example, no value, what to show when there is no value. I would say no active alerts. So as soon as I save this, you would see instead of no data, you would see no active alerts. Save dashboard, save. You see the difference? You can add any value instead of random no data. For example, in this panel, I did not add anything here as well. I wanted to show you we can add some value when there is nothing. You should see no active alerts. Let's add another visualization. So now I'm going to add memory. So we already did that in our previous episodes as well. CPU, sorry. This is the CPU. This would be, let's say, our CPU panel. I would like to add CPU and memory, and also visualization. I'm going to change it to gauge here, followed by let me add another query real quick that would be related to our memory. I'm going to save this, followed by let's scroll down and try to add threshold once again here. Let's try to add 85 as red color, and followed by let's try to add one more threshold value that would be 70. I'm going to save this, save, go back to the dashboard. Now we have so many different panels in place. Okay, let's try to rearrange that real quick. I would like to move this a bit here, and I would like to bring this PO latency on top, and also stats uptime. You can easily drag and drop. Also, if you want, you can resize the panels as well clearly, so that you don't need to scroll down much. If you have so many different services and so many panels, it would be difficult. So I would like to minimize this a bit. So let me increase this. Yeah. So P90 latency, application uptime, active alerts, CPU memory, error rate per minute. All right. Let's try to simulate the error now. I'm going to run this command. Press enter. We are trying to throw some latency on our application. If I jump back to my latency panel, I can see some spikes, but the color did not change. Maybe we did some mistake. Let's check it out. I'm going to edit my panel. So if I look at the query looks good here. Histogram quantile 0.9, app request latency per second. It looks good. Let me check the options here. Standard options, unit seconds, that's fine. And also I have threshold values 1 and 2. Let me check the color scheme here. I have it as green from thresholds by value. Yes, this was missing. Let me save that. And here we are. we can clearly see red color because every request is very slow. It is more than 3.8, 3.9, 3.6 different seconds, more than 2 seconds. So that's what we defined here. If it is more than 2 seconds, the threshold value, it should show red color. As expected, I'm going to move back here. And also, if you see, app service uptime is fine. CPU and memory, we do not have any active alerts because we do not have any alert rules in place. That's expected. The plan was to show this particular panel latency in the demo. So let me stop the script real quick and wait a few seconds. It should come back normal. It should become green now. Let's do a quick recap of today's episode. We just turned raw Prometheus metrics into a command center dashboard where we have uptime, latency, errors, and alerts in one single view. It doesn't just look cool, it tells you where to look first when production burns. Next episode, we will add multiple services, web, API, database, and watch cross service signals on this same dashboard. Subscribe now. We are about to simulate a real company infrastructure. Data without context is noise. Dashboards give it meaning. Thank you for watching and see you in the next video. You built dashboards, alerts, and notifications. But what happens when there's not just one service but 10? Welcome to production scale monitoring. In this final episode, we will take everything we built so far and expand it into a real world setup. A web front end, back end API, and a database. All monitored, all alerting, all visualized together. This is where your observability system evolves from a side project to enterprise grade scale. In the previous episodes, we have mastered Prometheus, Alertmanager, Grafana for a single application. But in real companies, it's never one application, it's many different services talking to each other. So today, we scale our entire design to handle multiple layers, just like a real production environment. Before we dive in, make sure you hit subscribe. This is the series finale, and what we are building today mirrors exactly what real DevOps engineers deploy in production. Now let's jump into our Visual Studio Code. In my Visual Studio Code, I have episode 10 enterprise monitoring folder. In this folder, we have the exact same stuff which we had in episode 9 with some more additions. First, let's start with docker compose.yaml. So far, we only had one service. Now we are going to add another service, API service. Followed by we have a database tier wherein we are trying to start DB as well. Then we have DB exporter. And in the end, we have our monitoring stack. Prometheus, Alertmanager, Grafana, Node Exporter. These are all the same stuff which we were doing from episode 1 till 10 so far. Now, Prometheus will monitor all three layers and Grafana will tie them together visually. Now let's jump into our Prometheus folder. In Prometheus folder, I tried to add a second job named API. Target would be API 5001 port, and another job is Postgres DB exporter 9187. This node exporter, we already have that from the beginning. Now let's jump back to docker compose.yaml. I would like to give a small explanation about DB exporter. What exactly is this? This exposes metrics like connection count, cache hit ratio, and query time on port 9187. Prometheus picks them up automatically. Our web has a slash metric endpoint, and also our API has a slash metrics endpoint. Just like we did earlier with Flask, in large systems, each service owns its own metrics endpoint. Prometheus simply scrapes all of them, making it effortless to scale from 3 to 300 services. Now let's look at the alert rules. I am trying to add two more alerts here. They are almost similar to the first alerts. The names are a bit different and also the expressions are a bit different. This gives every layer its own alert logic, all funneled through the same alert manager to Slack pipeline. We need a Docker file as well on each service. For example, API service will have its own Docker file, followed by database service will also have its own Docker file, and then web service will also have its own Docker file. I'm not going to explain everything in detail because I already did that. If you are new to my channel, please watch my Docker full course where I explained each and everything in detail. Alright, now let's try to start our stack. Docker compose up build-d. Press enter. As soon as I start, you see all the containers are, let's say, starting. API, web, alert manager, node exporter, DB exporter, Prometheus, Grafana. Now let's jump back to the browser. I can see a new login page here. So let me log in real quick. I'm going to log in and skip this. We do not have any kind of dashboards in place. That's expected. First of all, I would like to add a data source real quick. Add data source. Select Prometheus. Scroll down. And here Prometheus colon 9090 port. Followed by, I'm going to save this. As soon as this is done, we are jumping back to our dashboard panel. Now the fun part, building our multi-service Grafana dashboard. First, create a dashboard, add visualization, select Prometheus. First, I would like to start with application errors. For that, I would say give the title as app errors. In the query, I would say increase app errors total job is equal to web 1 minute. Followed by, we are going to add threshold value as well. Let's try to add some values here. One means it would be green. Everything is working fine. Base value, let's put it as 0. I'm not going to show it for each and every panel. I hope you guys understand what I'm trying to explain here. So let's try to save this dashboard. Name it as multi-service dashboard. Save this. Right now we are on multi-service dashboard. So I try to add a web service panel. For that, I would say add a row and I would like to give a title name here. What exactly is this? Web service update. So you will see web service related stuff in this particular web service row. Followed by, I would like to add another visualization real quick. So this time it would be uptime title followed by job. I'm going to add PromQL query up job is equal to web, and the same goes for the colors. Green would be number 1. If anything less than 1, that would be red color. Save this dashboard. Save. Go back to the dashboard. Now if we check, I have uptime. Now we have uptime dashboard in the same web service. And also I have application errors. So let me place it next to each other. We have web service in place. Now let's try to add a new visualization. So this time we are going to say API errors. So I would like to write title as API errors, followed by increase app errors, followed by increase app errors total job API 1 minute. I'm going to save this dashboard, save, back to dashboard. Right now it doesn't have any kind of rows. Let's try to add a row real quick. So I would like to give the title as API service update. And let's try to add another panel here. So that would be our response time. So title would be response time, followed by we'll add a query, app request latency seconds. Then save dashboard, save, back to dashboard, and then under API service we'll have, now each service has two panels. API service has response time and API errors, whereas web service has uptime and application errors. Now let's try to add another visualization. So that would be our connection count related to database. I'm going to give the title as connection count, followed by PG stat activity counter data name. That name that is equal to DevOps. I would like to save this as well. Back to dashboard. And then I would like to add a row. So row title would be our database service update. And let's try to add last panel here. So that would be the uptime of the database. I would say uptime, and the query would be up job is equal to Postgres. Okay, let's give it a gauge here so that we'll see some changes. And also let's change the value here. 1 would be green, 0 would be red. If it is down, we'll see red. Now let's try to save this, back to dashboard, and let's try to move this into the database service. Overall, we can see multi-service dashboard, database service, API service, web service. Now let's try to trigger a simulation. For that, I'm jumping back to my Visual Studio Code. Now let's try to simulate some errors. For that, I'm going to say docker execute -it and try to create a file, followed by I would like to do some curl request. As soon as we do this, let's jump back to our Grafana dashboard. Here we have different services. I see no issues here, and also I do not see any kind of errors. And if I go to web service, so if you see our application errors, I see different lines here, yellow, red as well. If I go back to my application errors, here I selected some of the options here. For example, show thresholds as lines, as filled regions, as lines off. I mean, we have multiple options. Based on the requirements, we can select all these options. And also I updated from green to red. Previously the base was red, so I updated back to red and green. And yellow one is, let's say, one error would be yellow, kind of a warning which we have. Save the dashboard. And just like that, from episode 1, no monitoring panic, to this moment, we've built a production grade observability stack. Prometheus collects, Alertmanager decides, Grafana visualizes, and Slack communicate. Together, they form the backbone of real DevOps monitoring. This isn't a demo anymore. This is how actual companies run observability at scale. Thank you for following the entire series. If you learned something valuable, drop a comment, share it with your team, and tell me what simulation you want next. And remember, observability isn't about tools, it's about understanding your entire system in one glance. Thank you for watching and see you in the next video.